Alright, so this is problem 3 from 2026 AIME 1. A hemisphere with radius 200 sits on top of a circular disk with radius 200. The hemisphere and disk have the same center. And so before we move on, I'm just going to draw that. Let's draw a disk here in space, and let's draw the hemisphere, and this is their shared center. Let T be the region of points P in the disk such that the sphere of radius 42 can be placed on top of the disk at the point P and lie completely inside the hemisphere. So let's just draw a sphere here, and I'm going to draw it on the outermost point since we can still place it here and it's still going to be inside. And so this point here is going to be P. This is one of the points P that we can place the sphere of radius 42 and still be inside the hemisphere. We know that all the points in T are determined by P, which is going to determine this sort of circle. Since you can place it here, you could place one here, you could place one inside definitely, and that certainly will going to be in here. And you could place stuff on the edge, and it's certainly going to be tangent. So we know T is a circle. And we want to find the area of T divided by the area of the disk. So we have the area of T divided by the area of the disk. We know that's radius 200, so we can already do that. It's just 200 squared pi. We want to find the area of T, and this is going to equal P over Q. So we have the area of T. So usually these problems in 3D geometry are made a lot easier by taking a cross-section and turning them into 2D problems. So here I'm going to take the cross-section just across the diameter of this hemisphere. So let me draw a semicircle here. Let's draw our sphere of radius 42. Let's draw our center here. And I'm going to call this center O. I'm going to call the center of this one C. And a good idea is to always just draw in like all the radiuses if you have circles, especially that ones that are cotangent to each other. So you can just draw all the radiuses. So we have a radius here. We have a radius here. We know that this is a radius, and we also know that this is a radius. I'll call this point T, and basically the radius of this circle T is going to be OT, since they're both going to have the same center. So if we find OT, we can find the area of this bigger circle T, and then we can find P over Q. So to find OT, let's just plug in all the numbers we know. We know this is 42, we know this is 42. We know this entire thing is 200. So OC is 200 minus 42, which is 158. And we want to find OT. We also know that this is a right angle since this is tangent to this line, and so the radius is going to form a right angle. So let's just take this and put it here since this one is getting crowded. We have a triangle here, hypotenuse 158, right angle here, and this 42. And we just want to find what this is. And we can just do this by a simple application of the Pythagorean theorem. So this is going to be the square root of 158 squared minus 42 squared. But squaring this is going to be kind of difficult. I don't want to square 158. I don't want to square 42 and do that. So we're just going to use the difference of squares. So this is going to equal square root of 158 plus 42 times 158 minus 42. And this is the radius of the small circle. And the area is going to equal pi r squared. So the area of the circle T is going to equal pi times this thing squared. So it's just, we can just cancel the square root. So 158 plus 42, 158 minus 42. And so the area of T over 200 squared pi is going to be 158 plus 42, or let's simplify this since we're going to be writing it down anyways. So this is going to be 200 times, what's 158 minus 42 is 116, and pi, that's the area of T over the area of our bigger circle, or the entire disk, which is 200 squared times pi. So 200 squared times pi is going to equal P over Q. So we can just cancel 200s here. We can also cancel pi, and we can simplify this. We have 116 over 200, which simplifies to, 58 over 100, which further simplifies to 29 over 50. And we can't simplify this one anymore. So our answer, what are they asking for? They're asking for p plus q. So we know that p over q is equal to 29 over 50. P plus q is 29 plus 50 equals 79. So our answer is 79. And since it's the AIME, we have to put the 0 in the front.